This is the Average Atomic Mass Lab. In this lab we're going to be studying a new element called candium, which is a made-up element that's made up of candy. Candium has 3 different isotopes. Isotopes are atoms that have the same number of protons, so the same identity, but different number of neutrons, so slightly different masses. So our candium sample here is made up of 3 different isotopes, and the isotopes are the 3 different candies: M&Ms, Reese's, and Skittles. So what I'm going to do first is sort them into 3 piles according to their identity. So I'll put the M&Ms here, we'll do the Skittles right here in the middle, and then we'll do the Reese's over here. So the first step is just to sort out your candies by what type they are. In reality, you couldn't do this with atoms, but it makes explaining average atomic mass a little bit easier if we can see the different isotopes and see how their relative abundances affect the overall average mass of the element. Okay, so we've sorted our sample of candium into the M&Ms, the Skittles, and the Reese's. And you can see that our sample of candium here was made up of 3 isotopes, but one of the isotopes, the Skittles, was a lot more common than the Reese's or the M&Ms. This is common of most real elements. Most elements have more than one isotope, and usually the isotopes are not evenly distributed. Usually one of them is more abundant than the others. So what we're going to do next is we're going to count up how many of each type we have, and we're going to find their mass. So we'll start with the M&Ms. So the M&M isotope, we have 1, 2, 3, 4, 5, 6, 7 M&Ms in our sample here. And we'll put them on the balance. And our 7 M&Ms have a mass of 6.22 grams. 6.22 grams for our 7 M&Ms. So you can use that information to find the mass of a single M&M. We'll do the Reese's next. So there's 2, 4, 6, 8, 10, 12, 13 Reese's. And we'll put those on the balance. 13 Reese's with a mass of 9.61 grams. 9.61 grams. And now our most abundant isotope is the Skittles. So I'll count these out as I'm putting them on the balance here. So we have 3, 16, 19, 22, 23. We have 27 Skittles. So 27 Skittles in our mixture here, and they have a mass of 29.46. So what you need to do for the calculations, you need to calculate the mass of a single Skittle, a single Reese's, and a single M&M. And then once you know the mass of a single piece of candy, you're going to calculate the relative abundance, or the percentage that each isotope makes from the whole mix. The Skittles were the biggest part of the mixture. They had the highest abundance because there were a lot of Skittles in our mixture. And so the one with the highest abundance is going to contribute most to the average atomic mass. It's a weighted average, and you'll find that the weighted average, or the average mass for this candium mixture, is going to be closest to the mass of the Skittles, not as close to the mass of the Reese's or the M&Ms, because they were a lot less common. So this is obviously an analogy to real atoms and real isotopes.